Hello, today we're going to talk about direct variation. So we have some vocabulary. If you want to write the first one down, pause the video, and then play to listen. The first vocabulary says two variables, x and y, show direct variation provided y equals ax and a does not equal 0. Okay, the next one, write it down, pause the video, then hit play. The non-zero number a, so it can't be 0 like we said here, is called the constant of variation. So a is the constant of variation. And y is said to vary directly with x. This term right here, y is said to vary directly with x, just means that you have the setup y equals ax. And a is the constant of variation. So here's an example. We have y equals 5 over 6x. This is direct variation because it looks like y equals ax, right? There's nothing else there. No plus b, no y-intercept, nothing there. So this is direct variation. And the question it could also be is, what is the constant of variation? Well, a is the constant of variation. What's a? Well, it's the one next to the x, just like your slope, same thing. 5 over 6. So the constant of variation is 5 over 6, 5, 6. Okay, now let's look at this example. Y equals 2/3 x plus 8. Well, because of this plus 8, that's a y-intercept, that's no bueno. It's not direct variation. It says it's direct variation if y equals ax. So that's why, because of that plus, it was a plus there. Kind of messed it up. Because that plus 8 is there, it's not direct variation. Done. Nothing else you can do. You don't even want to say that the constant variation is 2/3 because it isn't. It's not direct variation. There is no constant of variation. Constant of variation means that constant means same, right? So it's always going to be the same slope. The same variation is the same slope as 5, 6. All right, cool. Next slide. Tell whether the equation represents direct variation. Sorry, I want to just get a little closer. Whoa. Hey. Okay. So tell whether the equation represents direct variation. If so, identify the constant variation. That's exactly what we just did, except these equations here are not set up in slope-intercept form. So we do have to turn them into slope-intercept form. So I'm going to do that pretty quickly. We have 3x plus 5y equals 0. I subtract 3x from both sides. And I'm left with 5y equals 0 minus 3x is negative 3x. Divide by 5, divide by 5. Y equals negative 3/5 x. So now the directions that tell whether the equation represents direct variation. Is there a plus something? Nope. The y-intercept is 0, so yes. Direct variation. DV, direct variation. If so, identify the constant of variation. What's my constant of variation? Well, that's the letter A. What's the letter A? Negative 3/5. Woohoo! All right, number 2. We've got x plus 2y equals 1. So I've got to rearrange the equation in order to determine whether the equation represents direct variation. Excuse me. So these cancel. I subtract y from both sides. I get 2y then equals negative x. I always write the x first. And then is 1 positive or negative? It's positive, so it's plus 1. Now I divide everything by what's in front of the y, which is a 2. And really, I don't have to continue. I see I've got an extra thing here, but I'm going to anyway, because why not? This is fun. Negative x is really like negative 1x, so it's negative 1/2 x plus 1/2. Because of this, right here, it's not direct variation, and I'm done. Done. Last thing to do, and this is technically the harder part, depending on how comfortable you are with all this. Example, the graph of a direct variation equation is shown. So here's this graph. Ignore all of this. Write this graph down. Write those directions down. Okay, then pause the video and hit play. Now this ordered pair here says -1, -3. There's a line going through. We know it's direct variation, so that means it has to go through the origin. Okay, just make sure that line goes through the origin. All right, so now part 1 says write the direct variation equation. So direct variation equation, remember it's y equals ax, but a had a number in it, so we need a. Well, we're going to use the point to find a. We have -1, -3. This is an x, and this is a y. So I'm going to plug in -1 for my x and -3 for my y. And then I have -3 equals a times -1. A times -1 is -1a. Divide both sides of the equation by -1, and a equals +3. So there we go. I got my constant variation. Can I write my direct variation equation? Yes, I can. It's y equals 3x. Part 2, find the value of y when x equals 12. Well, that one's easy. I already know the equation. I could look at the graph, but I don't go out to 12 on the x, and I don't want to do all that. Instead, just use your equation that you just set up. X equals 12. 3 times 12 is 36. Woohoo! And that's it. Yay!